Get ready for this. We're going deep on this paper by Bryce Wiener.
Mm-hmm.
And it suggests that the great cold spot, you know, that weird spot in the cosmic microwave background,
Yeah.
it could be evidence for the many worlds interpretation.
Oh, wow.
You know, that idea that like
Yeah.
every quantum decision, every time something happens on the quantum level,
Right.
it splits reality,
Yeah.
creates a whole new universe.
It's an incredible paper. What I find most fascinating is how it connects an actual observation, something we can see in the data, to one of the most abstract concepts in physics.
It does sound a bit like science fiction.
It does.
But the argument it builds it's really compelling.
Yeah.
So before we go any further, just to remind me,
Sure.
what exactly is the Great Cold Spot?
So it was discovered back in 2004.
Okay.
And it's this area in the cosmic microwave background radiation,
Right.
which, of course, as you know, is the afterglow of the Big Bang.
Mm-hmm.
And it's significantly colder than it should be, based on our current understanding of cosmology.
Are we way colder?
Yeah. I mean, imagine you bake a cake,
Yeah.
and then you find this one patch that's like freezer burned.
Oh.
It just doesn't fit.
So it's not just a little bit cooler. It's really anomalous.
It's an anomaly. Yeah.
So we know there are things that cause variations in the CMB,
Yeah.
like the integrated Sachs-Wolf effect.
Right. If I was W.
But this is much colder than that could explain.
It is.
So how does this paper connect the cold spot to the many worlds interpretation?
Okay. So.
It feels like a pretty big leap.
It is. Yeah.
We're going from the universe's baby pictures to like the deep end of theoretical physics.
Well, the paper really focuses on this idea of quantum decoherence.
Okay.
Think of it like this. You know how quantum systems can be in multiple states at once?
Yeah.
Decoherence is the process of them settling into one definite state.
Okay.
Because of interaction with their environment.
So like imagine a coin spinning.
Yeah.
And eventually has to land on heads or tails.
Exactly.
Okay.
Now, the many worlds interpretation, it takes this settling and it sees it as a branching of reality. So those multiple states, they don't just disappear.
Right.
They split off into separate universes.
Oh, wow.
Each was a different outcome.
Okay, I think I'm following so far.
Good, good.
So is this paper saying that the Great Cold Spot is a place where this branching is happening differently?
That's the core idea, yeah.
Wow.
But what's really interesting is they propose an actual formula that links the temperature difference
in the cold spot
to the rate of quantum branching that's happening there.
Wait, so you're saying that a simple temperature reading could tell us how reality is splitting?
It's a pretty radical idea.
How did they even come up with that?
So they use something called Anhoof's holographic principle, which suggests that all the information inside a region of space can be represented on its boundary. So they apply this to the cold spot. And they argue that the temperature variations are actually reflecting different rates of information transfer. And they connect that to the branching rate.
That is mind-blowing.
It is.
And didn't they calculate a specific branching rate?
They did, yeah.
Based on the cold spot's temperature?
They did. What was it?
It comes out to about 1.89 by 1029 per second.
That's like incredibly small.
It's tiny.
But we are talking about processes that happen over billions of years.
Exactly.
So I guess even a tiny difference could have noticeable effects.
Exactly.
Okay, but if that's true, wouldn't every cold spot in the universe be a sign of another reality branching off?
Well, not necessarily. I mean, the Great Cold Spot isn't just cold.
Yeah.
It has other peculiar features. And this paper suggests that it's unique. That it's potentially like a special window.
Into this quantum branching.
Like this branching phenomenon.
Yeah.
So what kind of unique features are we talking about?
Well, there's this mysterious ratio that keeps popping up.
A ratio?
Yeah, it's about 1.285.
Okay.
And it appears in multiple observations of the cold spot.
What kind of observation?
That you have the ratio of its actual temperature difference to what the ISW effect predicts. You have the ratio of the observed size of the void.
The void.
Yeah, the void associated with it.
Okay.
To the maximum size predicted by our standard cosmological model. Even the ratio of polarization patterns inside the cold spot compared to the surrounding areas.
So this number, it's like imprinted on the cold spot in multiple ways.
It is, yeah.
Is there any explanation for that?
The paper doesn't give a definitive one. It suggests this ratio could be a fundamental constant related to quantum decoherence. Or maybe it's a characteristic of the cold spot itself.
Okay.
Or even just a mathematical coincidence or an artifact of our measurements. We don't know for sure.
So this paper doesn't definitively prove the many worlds interpretation.
No, it doesn't. The authors themselves say that we need much more sensitive telescopes to map the CMB's temperature variations and polarization.
With greater precision.
With much greater precision than we have now.
Right.
Yeah. It's still a fascinating starting point, though. I mean, what's really groundbreaking here is the possibility of actually observing quantum phenomena on a cosmic scale.
That's huge.
It is.
If this is true, it would completely change our understanding of
really would.
How reality works.
I mean, imagine the vastness of the universe.
Yeah.
It might not just be in space, but in the sheer number of realities
that are out there.
Yeah, that coexist with our own.
So if the Great Cold Spot is a window into this branching multiverse, could there be other windows?
That's a great question.
Like other anomalies that have quantum explanations?
It's certainly possible.
So are we saying that the Big Bang itself could be a result of some kind of quantum branching?
That's a very interesting thought.
Like, could the birth of our universe be just one outcome among countless others?
This paper doesn't really delve into the origins of the universe, but it's not crazy to think that the conditions that led to the Big Bang might be connected to a quantum event.
Okay.
Maybe a fluctuation.
In a pre-existing
quantum field that led to this cascade of branching.
And created all these different universes.
Yeah, with different physical laws.
And if the universe began with a quantum branching, could its end be a similar story?
It's possible.
Could there be different endings? Playing out in different branches of reality.
Again, this is going beyond what the paper talks about.
Okay.
But it's definitely fun to speculate. The fate of our universe, you know, whether it ends in a big crunch, a big rip.
Or just kind of fizzles out.
Or a slow heat death.
Yeah.
It might not be a fixed destiny, but a set of possibilities.
So different universes, different endings.
Potentially.
This is a lot to process.
It is.
So not just a multiverse, but a multiverse with a beginning and an end.
Shaped by this quantum branching.
It's like an existential crisis.
It kind of is.
But let's get back to this paper for a second.
Sure.
You mentioned that we need better telescopes.
We do.
What kind of advancements would we need to actually test this idea?
So to map those tiny temperature variations and polarization patterns.
That could hint at.
That could hint at this branching.
Yeah.
We need telescopes that are orders of magnitude more sensitive than what we have now.
Like how much more sensitive?
Imagine being able to detect temperature differences of less than a millionth of a degree.
Wow.
That's like trying to measure the heat.
From a snowflake?
From a single snowflake.
Yeah.
Falling on a mountain.
That seems impossible.
It's incredibly difficult.
Wow. Yeah.
It would require huge breakthroughs in detector technology, cryogenic systems.
To keep the detectors cold.
To keep them super cooled and get rid of all the noise.
Right.
And then sophisticated data analysis techniques.
Actually find the signal.
To sift through all the cosmic static. And find those faint signals.
So it's a huge challenge.
It is.
But not impossible.
Well, I mean, considering the pace of scientific advancement, it's not impossible.
Okay.
It's just really, really hard.
This sounds like a project that would take multiple generations of scientists.
Probably would.
But the payoff would be immense. If we could confirm these tiny temperature variations and link them to this quantum branching.
It would be revolutionary. It would?
I mean, it would be one of the most significant discoveries in history.
Right up there.
Right up there with understanding the atom.
Yeah.
Or mapping the human genome.
And speaking of mind-blowing implications. We've kind of danced around this idea of communicating between realities.
Right.
Is that even remotely possible?
Now we're getting into
I know.
Speculative science fiction territory.
Yeah.
But let's think about it for a second.
Okay.
In the many worlds interpretation, these branching realities, they're not totally disconnected. They're still part of the same underlying quantum wave function. Imagine a tree with countless branches. Each branch is a separate universe.
Right.
But they all come from the same trunk.
So there's some lingering connection.
Yeah, that's the idea. Now, Whether that connection could be used
to send information.
Yeah. That's a whole other question. That's a much bigger question.
We're talking about sending signals across the boundaries
of reality
that define different realities.
So no Morse code with entangled particles.
Probably not.
Okay.
Think about it.
Yeah.
Every measurement, every choice creates a new branch.
Okay.
Even if we could send a message, who's to say we'd be in the right branch?
Receive the reply.
To receive a reply.
That's a good point.
It raises questions about time and causality in a multiverse that we can't even begin to answer.
It's fascinating, though.
It is.
If we could send a message, what would it even look like?
I mean, that's purely hypothetical.
Of course.
But let's say we could manipulate the branching rate itself.
Okay.
Maybe we could create a pattern
of branching,
like a cosmic barcode.
Okay.
Where a high rate represents a 1, and a low rate represents a 0.
Like cosmic smoke signals.
That's
amazing.
And a sufficiently advanced civilization might be able to read those patterns.
And decode the information.
Exactly.
Wow.
Again, this is all speculation, but it shows the incredible possibility
of this quantum branching.
Of thinking about the universe this way.
Okay, but even if we could send a message, wouldn't it be incredibly difficult to detect?
It would.
And how would we ever know if anyone received it?
Those are the biggest challenges. These cosmic barcodes, if they even exist, would be incredibly faint and spread out over vast cosmic distances.
So we'd need unbelievable technology.
We could detect them.
And to decipher them.
Yeah.
And as for receiving confirmation, I mean, that pushes us even further into the unknown.
Yeah.
Remember, every choice creates a new branch.
Yeah.
Even if we could send a message, there's no guarantee that...
It's us in this branch. The us in this branch would be in the right branch to receive a response.
It's like sending a letter into a black hole.
Exactly.
You never know if it got there or what happened to it.
And that really highlights the challenges and the paradoxes of this whole idea.
Of communicating between realities.
Of inter-reality communication.
It really does make you think, like, what are the limits of what we can actually know?
It's a great question.
But let's step back from the hypothetical for a minute to get back to the paper.
Okay.
It suggests that this quantum branching idea could have implications for other cosmological mysteries, too.
Right.
Are there any specific examples that come to mind?
Well, there are quite a few, actually.
Okay.
Take dark energy, for example.
Yeah, dark energy.
We know it's causing the universe to expand faster and faster.
Right, accelerated expansion.
But we still don't know.
We don't know what it is.
What it is.
Yeah?
There are some theories that suggest that dark energy might be related to the energy of the quantum vacuum.
The quantum vacuum.
Which is the energy that's inherent to empty space itself.
So empty space isn't actually empty.
Well, according to quantum field theory, it's not empty at all.
It's full of.
It's actually teeming with virtual particles.
Virtual particles.
Popping in and out of existence.
So you're saying that dark energy could be like the combined effect of all these virtual particles.
It's possible.
Pushing the universe apart.
It's a pretty compelling idea.
And if dark energy is linked to these quantum fluctuations in the vacuum, it could tie back to this branching reality idea.
Occurred.
Imagine if the energy of the vacuum. And therefore the branching rate. It's not the same everywhere in the universe.
There could be regions.
Okay.
With higher or lower
vacuum energy.
Leading to variations in how often realities split.
And those differences in the branching rates could maybe explain
it's possible
like large-scale structures in the universe or variations in the cosmic microwave background.
Exactly. Again, we're speculating here.
Sure.
But it's an exciting possibility.
It is,
We've been focused on the great cold spot.
Yeah.
But who knows? Maybe there are other anomalies out there.
Other patterns.
Other subtle patterns in the cosmos that could hint at this quantum process.
I'm starting to see how this paper, even if it turns out to be wrong about its main idea, could still lead to all sorts of new research.
It could really open up new avenues of investigation.
It's like we've been looking at the universe with one eye closed.
I like that.
And now we're starting to see the full picture.
Yeah. And who knows what we'll find.
When we really start looking.
When we really start to level.
Maybe this quantum branching is just the beginning.
It could be the tip of the iceberg.
Like there's even deeper, more fundamental stuff going on.
That shapes reality itself.
It's kind of exhilarating.
It is.
And terrifying at the same time.
I know. It's mind-boggling.
The universe is already huge.
Yeah.
But if we're talking about a multiverse shaped by this quantum branching...
It's a whole other level.
That's a level of complexity.
It is.
That's almost impossible to grasp.
It really is.
But it's also really humbling.
It is.
And inspiring.
It reminds us that we're just at the beginning of understanding the universe.
And our place in it.
Exactly.
This deep dive has been a real journey.
It has.
It's made me question everything I thought I knew.
About reality.
About reality.
About the cosmos. And about what might be possible.
It's been great exploring these ideas with you.
Likewise.
And to our listeners, I'll leave you with this thought.
Okay.
If reality is branching, with every quantum decision, what does that mean for you?
That's a good question.
Are there countless versions of you out there?
Living out
every possible path.
It's a thought-provoking idea.
It is. It might keep you up at night.
It might.
But in a good way.
Hopefully.
Until next time, keep exploring.
Yes.
Keep questioning.
Absolutely.
And never stop looking up at the stars with wonder.
I love it. I love it.